Let's discuss the question number 32 from test 6. This is from theory of machines, basically the vibration part. Okay, so system is given where you have an elastic bar, then a spring, and then a mass, and then a spring again, and which is fixed. So you have an elastic bar of length 2 meters, okay, and then the stiffness of K1 and K2 is given, and so area of cross section of the bar is 2 into 10 power minus 5 meter square. The modulus is 100 into 10 power 9 Newton per meter square. K1 is 3 into 10 power 6 Newton per meter. K2 is 1 into 10 power 6 Newton per meter. Now how do I replace this elastic bar? Because it's an elastic bar, so I need to replace it by spring. Okay, so how do I replace? The elastic bar is there. When I apply the load P, okay, it deforms by delta, and this delta for an elastic bar is given by PL by AE using Hooke's law. This is from using Hooke's law, because stress is E strain, this is P by A, this is E, this is delta by L, so which gives like delta to be this. So the stiffness, so this I need to idealize by a spring, okay, of K. Stiffness K is load per unit deflection. So it's nothing but P by delta, so it's nothing but AE by L. So K is AE by L, K of bar. So this will be A is 2 into 10 power minus 5, E is 100 into 10 power 9, the length is 2 meters. So this is nothing but two gets cancelled. This is nothing but 1 into 10 power 6 Newton per meter. Okay, so I know KB. Now, so this entire system is basically you have KB, you have K1, you have the mass M, and then you have K2. So these are in series. So the effective will be KB K1 by KB plus K1 will be the effective stiffness. So this I can put this mass. So this is K2 and this is K effective. Okay, this is K effective. So now this is in parallel. Why it is in parallel? Because once you deflect this, the deflection of, once you deflect the mass by say amount x, the deflection of both is same, and the load is shared. The load will be shared, and the deflection is same. So it is in parallel. So this can be written as mass M into the K effective plus K2. So the total stiffness is nothing but K effective plus K2, which is nothing but KB plus K1. This is K2, right? KB plus K1 by KB plus K1 plus K2 is my total stiffness. So let's substitute that, and so my omega, the natural frequency, will be the K total by mass M. So once I substitute this, so K total, let's substitute the value. So K total is KB is known, KB is 1 into K1 is 3 by 1 plus 3 plus K2 is 1, mass is 100, and this entire thing is 10 power 6. So I end up getting, if I just tell you, I end up getting 132.3 radians per second. So the answer is B. So the basic objective is, in this problem, the basic objective here was to how to convert this elastic bar into a linear spring, and then it's just a matter of converting this into a single system, because for a single system, single degree of freedom, I know the natural frequency formula. Okay, so thank you. Answer is B. Thank you.